Welcome to Business Math. It's actually the last day of class. For you online students, be sure you watch all the times and the dates and everything else for your final exam. One other thing that I forgot to mention previously is that you are going to have a series of 4-question post-tests. Now, you can take these. For you online students, you'll have to watch when they're going to be open. For you live students, they're going to be taking this Monday, right from 8 o'clock to 8:50. So, but online students watch to see when you're going to be taking them. Now, you say, what are these questions going to be about? Well, if you go to Blackboard, bring up the Business Math course, go to the section where it says Course Documents, and it's under Course Information. Sorry about that. Okay, the syllabus. So if you haven't done this already, you right-click, Save Target As. Go ahead and save it someplace, and then go ahead and open it. And you'll notice that there's a series of learning outcomes. Okay? And there are a total of 7. So on Monday, let me enlarge that a little bit better. On Monday, for you live students, now online you'll have to watch when you're going to take this, the post-assessment is worth 28 points. So it's not going to be an enormous amount of points. But there'll be 4 questions where these will all be multiple choice, not going to be any essay. 4 questions, and it is open book, open notes, open internet. 4 questions where you can solve business math problems involving fractions, decimals, and percents. Then there's going to be 4 questions solving business math problems using algebra. Okay? And there'll be 4 math problems using basic descriptive statistics. And there'll be 4 math problems involving installment buying, discounts, markdowns. And then there's going to be 4 problems involving depreciation, inventory, and overhead. And then there are going to be 4 problems involving simple interest, promissory notes, and simple discount notes. And then finally, there'll be 4 questions involving compound interest. And actually, we never did cover annuities and sinking funds, so I'm going to not have any questions including annuities or sinking funds. Also, I'm going to try to go over these questions carefully to make sure that there's nothing on the MACRS, that one advanced type of depreciation that the IRS uses. And in fact, if that question does land on your final, be sure you shoot me a note so I can make sure you automatically get credit for that question. I did that on your quizzes, by the way. So, and live students or online students, if you had a question about that accelerated cost recovery system, it's the advanced one. I can't remember what chapter it was out of, but it was out of the depreciation. If you had that happen and you did not get full credit for that question, be sure you let me know. So send me an email, and I'll make sure I get that fixed. And I think, Shay, I finally got your quiz fixed, the one where you emailed me the answer. So, and again, this is for you live or online students. It's going to be 50 questions for the final exam. You will have 2 hours. It's going to cover chapters 1 through 5, 10, 11, 12, 14, 16, 17, 19. Okay? So, the party.
Dr. G,
Yes, go ahead.
I just looked at my Blackboard and it shows that you haven't updated that.
Oh, which chapter was that?
One,
Oh, was it chapter 1?
yeah, it's 1E.
1E? Okay, shoot me another email, because I got another one corrected, but I must have overlooked 1E.
Okay.
Okay?
Thanks.
So shoot me another email on that one, okay? Likewise, with you online students, it's not if I mess up, it's just when I mess up. So then send me another email, because I do want to get your grade all straightened out before, if at all possible, before I turn it in. Now, it's not that I can't change your grade after I turn it in. So if you look at your grade after the grades all come out, this is true for live or online students. If you go, this can't be the right grade. This grade, it's entirely too high. So then Rachel, let me know, okay?
You think I'm going to come back and tell you if it's entirely too high? I'm struggling with this class. I'll be happy to get a C.
So
and you can mess up all you want, just make sure that it's a C or better.
That usually doesn't happen. It usually doesn't happen. So, anyway. Well, turn to page 509. Here's the concept. $1 today is not the same as $1 100 years from now. And in fact, you say, well, of course, you got inflation. No, forget inflation. Pretend that we're living in la-la land with no inflation, okay? $1 today is not the same, doesn't have the same value as $1 100 years from now. And like I said, it doesn't have anything to do with inflation. Now, inflation really makes $1 today worth more than $1 100 years from now. But forget inflation. Just the simple fact, I try to emphasize it like this. Way back when we did talk about time value of money, I try to emphasize it like this, and I say, okay, you win the $100 million lottery, right? And the payout for that is usually over something like 40 years at $2.5 million a year. Now, if you do win that $100 million lottery, your life is probably going to be ruined, just like all the other people that have won big lotteries. Their lives take an absolute turn for the worse, and very, very, very bad things usually end up happening in their life. And the majority of lottery winners, and it doesn't even matter how big the lottery is, the majority of lottery winners are flat broke within 5 years, and almost all of them are broke or bankrupt at the end of 10 years. So there's very, very few people that can actually survive winning the lottery. And there's so many tragic stories, but yet in our culture we still think that's going to be the happiest day of our life. But now, so let's suppose that you did win the $100 million lottery. Are they going to give you that $100 million right then and there when you win that $100 million lottery. What do you think, John Tate?
First off, you gotta make it to go pick it up alive before you.
What's that? Oh, you gotta go pick it up alive. That's a good answer. Yeah, you might have a heart attack before you even go pick it up, huh? So, but are they going to give you the entire $100 million if you just say, I want the lump sum right now? What do you think, Shay?
No.
No, not even close, right? So depending upon the current interest rates and so forth, guess how much they're actually going to give you of that $100 million. Guess how much they're going to give you. Courtney.
$100,000?
That's a good guess. Now that would be if we were in an environment where we had an extremely high interest rate environment, but they actually do give you more than $100,000. This is, by the way, a good little extra credit question because, in fact, you could post it at the discussion board. Out of $100 million, or what percent, that's the question, what percent of lottery winning are you allowed to keep? And you could even say, there's two answers. You could say before taxes and after taxes. So go ahead and just Google it and see what you get and type in, and if somebody already beats you to this extra credit, post it to the discussion board. What percent of lottery winnings do you keep? This is a good one here. What percent of lottery winners go broke?
All of them.
Almost all of them, especially after 10 years. After 5 years, most of them are broke. But what percent of lottery winnings do you keep? Here's one on, this has to do with tax. This is good. Lottery winning 101. First get a lawyer and a tax expert. That's about taxes. How much tax do you pay? Oh, here's 19 steps to deal with lottery winning. You can see. But go ahead and look it up. And the answer is going to be, minus taxes and hype, how much do you get to keep out of $640 million or something? Okay? So go ahead and look it up. It may take you a little while to do this extra credit, but I guess that's why I give it as assignment. Here it is. It says 206 million. Okay. There's $206 million. And if you live in New York City, you're going to keep 176. This is all after taxes stuff. And I was trying to get the figure without taxes as well. Yeah, pre-tax. Here you go. According to this article, well, you might get different answers. But here you go. You get only about half. Okay? And that has to do with present value of money. That's what we're going to talk about today. And future value of money. Present value of money and future value of money. Okay? And by the way, you have a very, very nice calculator here. So if we go over to our time value of money calculator, which by the way you will be allowed to use on your test, both your post-test that you're going to take. So if you came in a little late, if you're a live student, there's going to be 7 post-tests that you're going to take on Monday. You can take those anywhere. Each of the post-tests includes 4 questions from your learning outcomes from right there, from your syllabus. But on any of those 28 questions, you will be allowed to use this time value of money calculator. Okay? Now watch how the present value is changed versus future value. If we're not going to make any deposits at all, and let's just pick something very simple, like the $100 million. So we're going to have 1, 2, 3, 1, 2, 3. Oh, it won't even let me do 100 million. We'll do 100,000. How's that? So this is a fairly chintzy lottery where we're only going to pay out $100,000. Okay. In this lottery, now it makes it a little bit more complicated because if we talk about one of two things could happen. Now this would not be a good lottery at all if they say, well, we're not going to give you a dime until 40 years from now, then we're going to pay you the 100,000. See, we have two different kinds of present value versus future value problems going on here. The simpler of the two, which no lottery to my knowledge does this, they say, oh, you won the lottery. You won $100 million. But we're not going to pay it to you until 40 years from now. Well, dadgum, that would do me a lot of good, wouldn't it? I mean, 40 years from now, yeah, like I'm going to be alive at age 104. I'm 64 right now. So the only people, in fact, my children and my grandchildren would probably be going, yeah, right, Grandpa can't spend any of it. But, so that's the simpler of the two present value versus future value problems, because the present value future value problem is a little more difficult when you say we're going to pay $2.5 million a year for 40 years for the $100 million, or the present value. So the question is, what would it take to generate that $2.5 million a year? And to make the problem simpler, we can even talk about 100,000 instead of 100 million. We'll just talk in terms of thousands instead of millions, and then we'll just add a zero or add 3 zeros when we're done. Okay? So if we take $100,000, and let's make this extremely simple. Let's back up, and I want to talk a little bit about compound interest again, to make sure you understand going in the one direction. Now, I did this last class, and we're not going to do it all over again, but I think quickly, let's go ahead and do this, see how fast we can crank through this. You got $100,000 in savings that your grandpa gave you. Boy, that would be nice, wouldn't it? And so when it's times 10%, we're just going to do this for annually, okay? And when you go semi-annually, you get actually a better deal because you're compounding twice a year instead of once a year. But anyway, let's rip through this pretty fast. Okay, what's 10% of 100,000, Courtney?
10,000.
10,000. So there's your interest on year one, okay? That's your interest on year one. So you take the 10,000, add it to, so now you have $110,000. So this over here is year one. That's at the end of year one. Okay? We earned, this is at the end of year one, we've earned $10,000 in interest. Now we have $110,000. Now we take that times 10%. And what is 10% of 110,000? Let's see, Robert.
11,000.
11,000. You just lop off a zero. So that's 11,000. So that's the interest that's earned during year two. Now what you do to get the figure for year two, you got to add 11,000 plus 110,000, so that gives you 121,000. This is compound interest. We're compounding annually. So now you take 10% of 121,000. What do you get, Rachel? Just lop off a 0 right here. That's the easy way to take 10%.
121,000.
Well, 12100. You'll have to move the comma too, right?
It's 12,100.
Yeah, 12,100. So that's the easy way to do 10% of something, is just lop off a 0, okay? Move the decimal point one place to the left. So you notice every year we're getting more interest, okay? And so I said, if you were to do this for 40 years, the actual answer at the end of 40 years is to take this interest right here plus the 100,000. So this answer right here is 110% of this. 121,000 is 110% of this. Now the next one down, if we take 110% of 121,000, we'll get the next answer. And then if we take 110% of that, we'll get the next answer. If we take 110% of that, we get the next answer. In other words, 110% is 1.1. So after the third year, the answer actually, if you wanted to get it directly, it's 100,000 times 1.1 raised to the third power. This answer right here, 110,000, is 100,000 times 1.1 to the first power. This is 121,000. Second year is 100,000 times 1.1 to the second power. The third year is 100,000 times 1.1 to the third power. The 40th year is 100,000 times 1.1 to the 40th power. So in fact, if we grab a calculator that can do raised to the power, and you can do this. Now my calculator, my smartphone, when I first got it, I looked at the calculator that I had, and I said, oh man, it's just a simple calculator. I can't even raise to the power. Well, all I did was I turned my smartphone sideways, and it became a scientific calculator. I discovered that by accident. So when I press calculator, now you probably can't see this for the hoot, but anyway, well, maybe you can. There's a regular calculator, and when I turn it sideways, it becomes a scientific calculator. That's pretty cool. It was a nice little feature. So I can actually do this problem now. I can take, and by the way, the symbol for raised to the power is called a caret. Now on some scientific calculators, it'll be an x to the y key. So on some calculators, you'll look for a little x to the y key like that. On some calculators, you'll look for a little caret like that. So if I want to do this part first and times it by 100,000, I could go ahead and do that. So I can take 1.1, hit the little caret key, there's the little caret key, and put 40th power. And so that is about 45.25 in a bunch, okay? Then if I multiply that times 100,000, in other words, move the decimal point 5 places to the right, but anyway, times 100,000, and hit equal, I get this for the answer. I get 4, 5, 2, 5, 9, 2, and we'll round it to the nearest dollar, okay? So I get $4.5 million, okay? Now that's with the assumption that I have 10%. This is compound interest. By the way, just to show you what difference it makes, if we compound twice a year, instead of in 40 years, how many compounding periods will we have? If we're compounding twice a year, How many compounding periods will we have in that 40 years, John Day?
80.
80 is correct. So if we want to do the same problem, and I'll put this one in blue right below it, if we want to say, you know what, what's the difference? What difference would it make? That's going to be Hillary Clinton's campaign. That's what she said after the four Americans got killed in Benghazi. What difference does it make? It's going to be her campaign slogan when she runs for president. Anyway, so what difference does it make if we do the compound semi-annually? Well, you're going to get 5% for each 6 months. That's where this 0.05 comes from. Then we're going to add it back on to the original 100%. That's the reason it's 1.05. And we raise it to the 80th power because Jonte told us that there were 80 compounding periods. Now you would think it wouldn't make much difference at all to compound twice a year as opposed to once a year. But go ahead and do that on your calculator. Take 1.05 raised to the 80th power, all right? And you get 49. And now move the decimal point 5 places to the right. So you would get 4,900,500. Yeah, $4,956,144. So by just compounding twice a year, it's going to make quite a bit of difference, okay? Just to change the compounding from once a year to every 6 months. And then you could compound 4 times a year, in other words, quarterly, and then you would have 160 compounding times, and then you'd have to change this to 1.025 because you'd get 2.5% per quarter, and etc. You could keep compounding, and in fact, you could even compound daily if you wanted to. And then you'd have 40 times 365 compounding periods and so forth. All right, well, anyway. So let's see how this thing looks with the time value money calculator. Let's see if we can do this with the time value money calculator. All right, go back over here to the time value money calculator. I'm going to take, we don't know what the future value is going to be. We're going to take the present value and we are going to put in 100,000 just like we did. Okay, 100,000. I'm going to put 10% in here for the rate. We're going to pick 40 periods, but 40 annual periods. We're not going to make any payments whatsoever. So we're not making any monthly payments here. We just want to see what 100,000 is worth 40 years from now. So to see what 100,000 is for 40 years from now, just get future value, and lo and behold, look at that. That's the same answer that we got, that $4.5 million. $4.5 million. Now, interestingly enough, let's change this to semi-annually, but let's do this for 80 periods now, leaving our APR at 10%, but we're going to change it to 80 periods. We're going to do semi-annually, and now, there it is. There's the 4.9 million. Now, this is pretty cool, because this is actually easier than using the scientific calculator, isn't it? Because now if we leave the rate and we want to go, hey, let's compound quarterly. So if you compound quarterly 4 times a year, you'd have 160 compounding periods. And watch how compound interest changes just by changing how often we compound. So now instead of 4.5 million, now it's about 5.2 million. And then you could even compound monthly. Here's if you compound monthly, you would have to change, let's see, how many months are there in 40 years. How many months are there in 40 years, Courtney?
480.
480 is correct. So you'd have to change that to 480, and now the future value, well, now you get 5.37 million. All right? And you say, hey, let's go for it. Let's compound daily. Well, we're going to have to take 40 times 365, aren't we? We're going to take 40 times 365, compound daily. So that's what we're going to have. 14,600 goes in the period, 14,600. By the way, how did I get the 14,600, Shay?
You did it daily?
Right. So how do you come? What do you take times what to come up with 14,600?
40 times 3.
Bingo. 40 times 365. So you take the number of years, and we're going to compound daily. So we put this to daily, and now let's see how much we get on our future value. We get about 5.4 million, something like that. 5.45 million. All right? Now, some of you are thinking, well, can we compound every hour? Can we compound every second? Could we compound continuously, every millionth of a second? And the answer is yes. That's called compounding continuously. I'm not going to cover that today because it's more of an advanced math thing. All right? So you're disappointed, aren't you, Rachel? Well, anyway, now let's go back to the simple. Let's go back to the simple. I want to do just the 40 years. Back to the simple. And annually, and the future value was this. What we're going to do now is go backwards. We're going to put $100,000 in here. Now, we are not going to talk about inflation at all. And it won't matter if you put the negative or the positive in there. And technically, when you deposit money, you take it out of your checking account or whatever, and you put it in here. So technically, in the time value of money calculator, I should have been putting negative here, and then we compute the future value, and there it is. Okay? Then we have a positive 4.5 million. We put in the. Now you see it won't really matter either way. But let's take and put 100,000 as the future value. So there's your 100,000 as the future value. Now we want to figure out present value. Now we're not doing anything about inflation. Notice now when I click on present value, PV, this number is going to be highly dependent upon whatever rate you put in. If you put in a rate like 3% and figure present value, sorry. You never get discouraged when you mess up. You can always serve as a bad example. Okay, I wanted to click present value. When I do, let's go back to the rates. I screwed that up. With 10%, here's present value. It would take $2,209.49. Take it out of your checking account, and then it would grow at 10%. For 40 years, we compound annually, and there you go. There's the future value. So in other words, the present value, this calculator can figure it out backwards, which is really cool. Now watch what happens when we change the rate to like 3%. Now this time I'll click on the PV with present value is correct. Wow. It would take $30,000. So this is kind of the rule of thumb that they're giving you. Now you know why they will give you maybe even only a third of your winnings. You know, they'll give you only a third of your winnings. And in fact, if you go to 2%, it all depends on what they're figuring as their time value of money. The time value of money is measured as a percent. So if they're figuring their time value of money at 2%, Because basically, I don't have time to go look at it right now, but the 10-year rate right now, government rate, the 10-year government rate is about 2.6%. Okay? So if you tie up money, if you're willing to tie up money for 10 years, you'll get about 2.6% interest. If you're willing to tie up money for longer than that, you'll probably get about 3% on a 30-year. Okay? We're talking about a government loan. In other words, you're buying a government bond, you're loaning the government money. It's an investment in U.S. Treasuries. Okay? Sometimes they're called T-bills for Treasury bills. Okay? That's also known as the risk-free rate of return, because there's virtually no risk if for U.S. government bonds. They're considered to be no risk, even though you and I both know, technically, hey. But I tell you one thing: if the United States does fold and can't pay its Treasury notes anymore, we're not going to be worried about money. We're going to be worried about food, not money. It won't even matter. Okay. Well, anyway, so this is a beautiful, beautiful time value of money calculator that you can use. Now, your author, this is in 19-2. It shows you some examples. And then it shows you how to calculate this with the poke yourself in the eye with a sharp stick method. Now that's the one that you prefer, right, Rachel?
Mm-mm.
No, you don't prefer that. Neither do I. Well, in the real world, people use actually time value money calculators, or they will actually use a calculator. Let me show you an example of an actual calculator. Let's do a picture of a calculator. Let's go to Google Images, and let's bring up a picture of a financial calculator. So when I took my courses at K-State, I took my 6 graduate courses in finance. I probably can find the exact calculator that I had. It was an HP, and it looked almost identical to that one right there. I don't know, well, you can see that, but anyway, that's what it looked like. And what it does, it has all these wonderful keys on it. The one I had actually looks like that, okay? It has all these wonderful keys on it for present value, future value, and I don't make students go out and buy one of these, obviously, for this course. Some, actually, business finance courses, they require that you go buy a financial calculator. In fact, we were highly recommended to buy a financial calculator. Now, what's really cool nowadays is you can go, if you have an Android or an iPhone, you can go and download an app that is a business financial calculator as an app. So when you go, I have various business calculators, financial calculators downloaded right here. I downloaded one called Financial Calculators, and it has a time value money calculator on it, nice simple to use one. It has a currency converter, a loan calculator, compound interest calculator, credit card payoff calculator. Oh, by the way, Rachel, did you post that early car payment calculator at the discussion board?
At the discussion board, I emailed it to you, and
And you sent it to the president, right? That was the third thing you had to do. Anyway, so what's so cool nowadays, you don't even have to go out and spend a lot of money on a business calculator. But I did because it was real handy. And then what I did was I took a page out of my daughter's handbook of how to learn things, and I went to YouTube and typed in the exact model number of my HP financial calculator to learn how to use it. I didn't even read the manual. I just went to YouTube and looked at a bunch of YouTube examples. Well, here's the point. So look at page 510. Look at page 510. Here's an example. Here's an example. Now let's see if we can do this with the time value money calculator. We're going to figure out the present value. If we know the future value, this is just more fun than a human being should be allowed to have here. $108.84. Now I'm getting this from figure 19.5 on page 510. Oh, by the way, this is in 19-2. We've decided to go with custom books to save you students a lot of money on your textbook. And I know your current live students are thinking, thanks a lot, Dr. G. We had to pay a fortune for this book, and now you give us now you come out with a cheaper book. So I don't know if the custom book will be page 510. I'll have to go look now. But it's the second page of 19-2. I just thought of that now. The page numbers might not match. Well, anyway, I'm on the second page of 19-2, which happens to be page 510 of the book that we're using right now. So future value, $108.84. If we wanted to know the present value of that, we could change the rate. In the example, used 8%. And in the example, we're doing 4 periods. So let's say 4 years here. And now we want to compute the present value. So you just hit present value and you see it was $80. So that's kind of nice that it works. So if you actually want to poke yourself in the eye with a sharp stick, here is the formula. It's present value equals future value divided by 1 plus I to the nth power. Now, I only have about 3 minutes left, but at least to see where this thing came from, does that look at all familiar to this? Future value equals present value times 1 plus I raised to the nth power. Hopefully you're saying yes, because Courtney is our algebra expert. In fact, I won't forget that, Courtney, that you solved some algebra better than I did. Just don't tell anybody, okay, Courtney? It's our secret. But, so, if you were going to take this equation down in here that I'm circling in red, and you were to solve that for present value, how would you do that, Courtney?
Divide by both sides by PV.
You could do that. You could divide both sides by PV. In fact, I can't remember if maybe, let's see, who suggested that? I think that was Wyatt one time that suggested that. That would work. It would. In fact, that's what I was going to do. I was going to divide both sides by PV, but actually, it's shorter to divide both sides by what, Courtney?
The 1 plus I to the nth power.
Yeah, 1 plus I to the nth power. Because if you divide both sides by this, bingo, you're done. You got it. Now, some of you are still saying, well, wait a minute, Dr. G, this doesn't look familiar. Well, let me plug in real numbers, and I'll show you how familiar it was. We were computing the future value off of $100,000, remember that, times, it's getting a little bit messy, but 1 plus, and when I compounded, see this I is the interest rate per period, so when I compounded semi-annually, I used half of the 10%, and then the N is the number of periods, and I did that for 80 periods because there were 80 6-month periods in 40 years. So this should look very familiar. So that's how you end up. Whoa, what did I do there? That's interesting. That should look very familiar. But what's so super cool, I'm letting you use the time value of money calculator. Well, I can promise you that this has been a way more fun semester for me than you. Right, Rachel? not, it hasn't even been fair. That's the way life is. Life is not fair. Well, live students or online students, call me on my cell phone if you have any more questions you'd like to ask, but it's been a fun semester, and the final exam, open book, open notes, open internet. You can have your time value of money calculator ready. You can use the time value of money calculator, by the way, when you do the assignment for 19-2. That's great. And also, don't forget about your 28 questions. There'll actually be 7. There'll be 7 4-question quizzes for your post-test. So there'll be 7 little post-tests. For live students, they're taking that on Monday. For you online students, you'll take that. Also, remember for you online students, you're going to have to report, just like the live students, to Enid, Alva, Ponca, or Woodward. But online students, you get to also take the test through Remote Proctor now. So in case you're in Bulgaria or something, and you've been taking business, I've had a student take a course from me from Bulgaria once. But anyway, so if you want to do that, you can still take your final exam from Bulgaria. You'll just have to use Remote Proctor, and all the information is at the Northwestern website. Have a great summer. Good luck on your final exams. Give me a call if you have any other questions.
Dr. G?
Yes.